Next up, we will welcome Maria. Maria is a senior PhD candidate from Universidad Andrés Bello in Chile. The title of her presentation today is Low Thyroxine Levels During Pregnancy and the Intestinal Outcome in the Adult Offspring. Maria, welcome.
Hello, thank you for your presentation. I'm very happy to be here. Let me share screen. Wait. Okay, can you see?
Yes, all good. Thank you.
Thank you so much. Well, I'm Maria Mendoza, and today I'm going to talk about some of the study I've been performing on my PhD. This is about low thyroxine levels during pregnancy and the intestinal outcome. So to start, okay. So maternal thyroid hormones are essentials for the fetus development. And in the thyroid gland, mostly it is produced thyroxine T4 and triiodothyronine T3. And T4 is considered the reserve hormone, and by some enzymes can be transformed into its active form, which is T3. Why it's important? It's because when a pregnant woman these thyroid hormones can pass through the placenta to the fetus. And the important thing is that the fetus depend on maternal hormones, especially during the first trimester, when these organs like the intestine and the central nervous system are developing. So even when the fetus start their own production of thyroid hormones, the mother always supplies these hormones for this development. So I want to talk about a condition that is called gestational hypothyroxinemia. Maybe you haven't heard about this condition, but it's asymptomatic for the mother, and its prevalence is very high, from 1.3 to 25% in pregnant women worldwide. It's different from hypothyroidism because it's only characterized by low levels of T4 hormone with normal levels of T3 and TSH hormone. So these affect the fetal development because the fetus won't have enough concentration of this hormone for the development of different organs. So the literature have shown that in the human progeny, this condition can increase the risk of the progeny to have autism-like behaviors, attention deficit hyperactivity disorder, and also a lower IQ. But as you can see, these studies only focuses on the neurodevelopment. So we wonder what happened with other organs or systems. So thanks to the use of animal models, it's been possible to see that also in animals, this condition can increase the possibility of having autistic-like behavior. Also, when these mice are induced to autoimmune diseases like experimental autoimmune encephalomyelitis, they show an increased disease, and also they are more susceptible to develop ulcerative colitis. So these aspects are linked to the gastrointestinal system, and previous results from our laboratory have shown that these mice tend to have an increased paracellular permeability in the ileum. So I focus on the ileum, and I wonder how gestational hypothyroxinemia can affect the intestinal barrier. And when we study the intestinal barrier, there are a lot of elements that we can touch and see how the imprinting of the gestational hypothyroxinemia can affect in the offspring. But for this presentation, I will focus on the histological evaluation and also on implanted cells, considering that in the ileum, we have in the crypts these cells that controls the microbiota and by the production of antimicrobial peptides, and also by trophic factors that help the intestinal stem cells. So first of all, I want to show you the model that we work for inducing the gestational hypothyroxemia. We have pregnant mice, and we give them by drinking ad libitum water for the control mice and metimazole for the hypothyroxemia offspring. So what we do is using their offspring at the experimental time P55, we will have the control and the HTX offspring. And first, we evaluate how the treatment with metimazole affect the mothers. So we took a serum from these mice, and we see that only the T4 levels are reduced in the hypothyroxemia mothers. So we can continue with using these mice for the evaluation of the different assays. And here I will show you that when we evaluate some cytokines related to pro-inflammatory cytokines, we see that IL-6 and IL-17A is increased in the hypothyroxemia offspring. We use the adult offspring to see these effects. And also, because I'm focusing on the ileum, when we evaluate these cytokines in the ileum, is also altered, is also increased. These results suggest that these offspring should have an pro-inflammatory state, even without inducing any condition or infection or inflammatory things. So then we can show you how is the histological features. And what we saw is that the histological score is increased in the ileum of the offspring. These offspring show reduced number of goblet cells, also increased infiltrate of immune cells in the lamina propria, and a reduced mucosa area. So showing an pro-inflammatory state in the ileum. Also, when we look further and we look in the intestinal crypts, here I show you some micrograph. We see panned cells, and we can evaluate in these panned cells how are the morphological state of their granules. And what we can see is that when we measure the internal area of the granules that are characterized by an electron-dense core with an electrolucent halo, these granules are increased they are bigger in the hypothyroxemia offspring. And also, we can classify the granules of the panned cells, and we can see a reduced percentage of normal granules. And these granules in the literature, they have only been characterized like abnormal granules. They can have abnormal granules, and we saw a distribution of different abnormal granules. And even when in the literature it's not being described why these granules can be, it's proposed that maybe something is happening when the packaging of these granules in the hypothyroxemia offspring. Also, these results are we found how is the transcription of some antimicrobial peptides like lysosine and cryptidins, and we found an increase in these antimicrobial peptides. So it's interesting to see in further evaluations what happened with that intestinal microbiota. So for this presentation, just to take home, we saw that the hypothyroxemia offspring have a basal inflammation, and that shows bigger and abnormal granules in their panned cells. This study suggests that there are alterations at the level of the intestinal innate immunity, considering that the barrier is always a part of this protection from the environment and the things in the intestinal lumen. So I want to thank to all my group, my PI, and the people from the facility that helped me to took this TEM microscopy. My professors, I'm in Chile, but I'm Venezuelan, and I'm happy to show you some of the views here in Chile, and my team, of course. And well, looking for new opportunities in science in this 2026. Thank you so much.